As said, today's topic is power quality. We will try to highlight a little bit what it is, why it's important, and what we can do to improve it. We can say that, like any other raw material in a productive system, it is important to control and improve the quality of the electric energy in order to improve the quality and cut the cost of the production output. If you can go on the first slide, Ada, please. Thanks. According to Leonardo Power Quality Initiative, which is one of the leading initiatives taken by the European Commission, a poor power quality will cost around 150 billion annually on a European level. But this is not just a topic of Europe, as Gerrit highlighted, but this is a global trend. So not surprisingly, energy managers all around the world are becoming more and more aware of this topic and aware of the benefit that a good power quality management can create. But now we have to define a little bit what is power quality. And generally speaking, of course, this is a very large topic, but just to go into the details a little bit, we can see power quality as the compatibility between what comes out of an electric outlet and the load that is plugged into it. So in other words, we can say if the energy that comes out of the plug, okay, so to speak, doesn't match the requirement of the appliances that are fed by that energy, we have a power quality problem. And specifically in terms of most of the times in terms of voltage, frequency, of waveform of the energy supply. Why it is important to have a good power quality? It's important because we can have a large number of different problems related to the features that I already mentioned that can lead to damages of the appliances and to waste of energy and therefore, of course, waste of money. So we can have harmonic distortion, which are distortion of the normal waveform that are created by nonlinear loads, specifically by electronic loads. As Gerrit mentioned, companies are applying electrical loads more and more. So we are going through an electrification process and specifically through electronic loads. So we are seeing companies putting more and more electronic loads into their systems, and this is creating, of course, a problem of harmonic distortion that can lead to problems with motors, etc., etc. Then we have other kind of problems related to what we call transients, which are very fast high voltage increase that may lead to the rupture of motors. We have very frequent frequency variation that can change in a very short amount of time, going up and down. Then we can have also other factors related to poor power factor, overvoltage situation or undervoltage situation, meaning by that a constant situation of overvoltage or undervoltage. We have a voltage fluctuations with different kind of fluctuation. We will not go into the details because we will take a lot of time, or we can have some phase imbalance as a problem. All of these last topic will belong to a broad category that we call voltage optimization. This is the field of application where ICOPOWER, which is the company that I am representing here, is focusing on. And I will show you how voltage optimization can be considered part of a good power quality management system. So next slide, please. Okay, so why do we say that voltage optimization is so important? You may know that voltage supply is not stable by nature and can be influenced by several factors, such as, for example, the distance between the source of energy and the consumption point, the number of users that are attached to a specific line, the length of the cable, the dimension of the cable, the age of the cable. So there are a lot of factors that will influence the voltage stability. So these fluctuations, and in particular the peaks of this variation, can lead to several problems. And these are the problems that we are trying to address with the proper voltage optimization management system. So first of all, one of the problems is that we can have an extra consumption of energy and therefore a waste of money on the loads that are voltage dependent or voltage sensible at different degrees. For example, motors, pumps, chillers, resistance, transformers, and lamps. Of course, as you may know, all these loads can have different degrees of sensibility in relation to voltage. In other words, they can behave differently at different voltage level. We can say that independent authorities have already certified saving between 5 and 15%, depending on the situation, by managing these overvoltage peaks and constant overvoltage situation. Second important point is that this fluctuation can have an impact, a very high impact on the lifespan of the devices, shortening up the duration and creating extra maintenance cost. There are a lot of studies that shows how an extra voltage can lead to a premature wear and tear of the electrical devices, to extra maintenance cost, and to extra cost related to the fact that the devices are going to break up a lot more often. Next slide, please. So in the short term, the application of a voltage optimization machine or device may lead to several benefits. Number one, of course, which is the one that everybody is most interested in, is the saving of money, which is probably always the number one topic when a company thinks about an investment. But of course, there are several other benefits to consider, such, for example, the protection of the equipment and overall a better operation in terms of also reactive power, harmonic distortion, because these devices also have a benefit from this point of view. We have benefit from the protection of the environment, reducing the footprint of any productive activity. As Gerrit mentioned in his presentation, there will be more and more pressure from the politic in general, from the government, to look at what we call the ESG criteria, which is environmental and social and governance, to give credit to the companies based on how well they perform, even on environmental base. So we do not have to think that these are only topics related to energy management and very technical topics. These are issues that will be impacting all the life of the company, from the supply to the cost scenario to the overall, let's say, range of application of the entire life of a company. So the thing is that what you really need to do is to have an approach that will try to keep in consideration all these kind of topics. Another important point is the fact that built in the system, we have a monitoring system to improve production management. Then you can create KPI, best practice, etc. All this data, this is another important point that also Gerrit made. Now we are in a data age, okay? It's important to manage energy, but also to important data. You can collect all the electrical data of your company and merge this data into BMS, which are building management system, EMS, that are energy management system, or even blend this data with the data that are coming out from your SCADA systems. So these are obviously machines or devices that are taken into consideration, especially from a financial point of view or an economic point of view when we're talking about ROI of investment. But we would like you to consider also the other features of these machines from a data management point of view or environmental point of view. So as a conclusion, power quality and in particular voltage optimization can no longer, in our perspective, be ignored in a modern energy management system. The benefit of this implementation are well documented and economically and financially sound, and should be considered by any energy managers that wants to seriously take into consideration the opportunity to bring an extra value to his own company. So this is the conclusion of my topics. Thank you. Would you like to go directly to the business case? Okay. I would like to show you in practice how we translate all the things that I explained to you into an actual business case. We are now dealing with a large company in Italy, but this is an international company that has several production sites all over Europe. They are a large paper producer. They are consuming more than 2 terawatt-hour every year of electrical consumption only. Of course, we are not applying our machine on all the consumption. Some of this consumption are directly in high voltage or medium voltage. We are only working on in the low voltage side. But this is a complex case that can show you how a power quality management system can lead to impressive savings because we are solving a lot of different issues, a lot of different problems for our customer. In particular, if you take seriously what Gerrit said about local generation, and you are considering the possibility to implement what we call a DER, which is a local generation system, a decentralized energy resource. These are the topics that you may be interested in. So, for example, the problems that we solved for this company, first of all, we reduced to zero the penalties for reactive energy. Because of the fact that they have large photovoltaic plants, okay, they have a problem with a reactive energy penalty. This is created by the fact that, as you may know, photovoltaic plants are creating energy with a power factor of 1. So it's, let's say, doesn't need to have any power factor correction. But this is creating the fact, as you may see, that the same amount of reactive energy will be counted by the utility meter, and by the fact that they are taking less energy from the grid, this will change the ratio between active and reactive energy, and their overall power factor will drop below the penalty level, they are paying something like 130,000 euros every year as a penalty. And I will show you later how we are going to cancel this kind of penalties by an application of a special power factor machine. Next slide, please. Okay, another problem that they are facing is that a poor power factor is leading to an extra consumption of gas because they have a lot of big cogeneration plants. They need to create more kVA that are the apparent power required to run their motors. Because of the fact that they have a poor power factor, and therefore they need a lot of kVA, they need a lot of gas, they need to run these motors at full speed to be able to provide active power to the motors. And therefore, if you see the comparison here between two different power factors, by enhancing the power factor, we are able to reduce the total apparent power needed, and therefore, generating locally this power, they will save gas. Normally, you don't take this into consideration when you are just relying on the grid sources, because the grid will only make you pay the apparent power only if you have a bad ratio between active and reactive power. But when you are creating locally your own energy, this will change the entire perspective. So in this case, reactive power management is directly an energy saving technology. Next slide, please. Okay. The other problem is that by having a lot of local generation plants, they are closer to the source of energy, and as we have seen before, being closer to the energy source will create a situation where your voltage, your supply voltage, is very, very high, and as we have seen before, this will lead to an extra consumption on all the devices that are voltage dependent or voltage sensible in some degree. All of these problems, next slide please, is creating a situation where they had an extra consumption that we are addressing at the moment of nearly 3 million euros every year, that are related to electric saving generated by the ico-f solution, which is a voltage optimizer, and then we have the reduction in reactive energy penalty, and then we have an extra production from cogeneration and solar given by a better power factor management. So obviously this is a very complicated project. It will take a rollout period of 3 years approximately. There are hundreds of installation. We are going to install hundreds of machines, different sizes, different positions, different lines, etc. But the overall overview of this project is what you've seen. By managing power quality, we are really able to provide measurable, and this is the most important part, savings for our customer. Next slide, please. Okay, this is, let's say, the last sentence that I would like to leave you with. It is extremely important to have a measurement protocol that is very solid, very accurate. We are working with the leading protocol, globally speaking, which is called IPMVP, that some of you may be familiar with. But we think that unless you can certify your result, we are only talking about opinions. when we measure and when we apply a protocol, we are talking about numbers, we are talking about ROI, and we are talking about strategies. We are not in the field of opinions anymore. Thank you very much for your attention, and if you have some questions, we are more than happy to answer to you.